Hi everyone, welcome to GoClasses. So in this lecture, we will see the summary of partial order relation, summary of POSET. This is our POSET summary lecture part 2. In the part 1, we have seen the definition of POSET, the definition of partial order relation and some concepts we have seen. Now, let's continue that. So now we will see what is hash diagram for a POSET. What is this hash diagram concept? So let's see. You already know that for any relation R, you have many representations, correct? Whatever relation you take, that will have many different representations like set representation, graph representation, matrix representation. Okay, so for example, consider this relation. You can consider this relation, R on set. What is your set? What is your base set? Your base set is 1 2 3. So consider this relation. You can see this is the matrix representation of this relation and this is the graph representation, right? So I can say this is our matrix representation, and for the same relation, this is the graph representation. You can easily see 1 is related to 2. In the matrix also you can notice that 1 is related to 2. Okay, you can see 3 is related to 1. Okay, 3 is related to 1. You can see in the matrix also you can see 3 is related to 1. Okay, and you can see every element has a self loop. Okay, so you can easily see that 1 related to 1, 2 related to 2 and 3 related to 3. So very simple. If you take any relation, whatever relation you take, that will have many different representations. So you can see for this same relation, this is the matrix representation, this is graph representation. I can also write the set representation. What that will be? The set representation will be like this: 1 is related to 1, 2 is related to 2, okay, 3 is related to 3. Also you can notice that 1 is related to 2 and you can see 3 is related to 1. Okay, so this is the set representation that I can write, because you already know that this relation, this is basically from set A to set A. Okay, in the relation you will have ordered pairs. Elements of A are related to elements of A. So you can see this is the set representation. Okay, what I can call it, this representation, I can say this is your set representation. Okay, so very simple point. Every relation that will have different representations. But what is the beauty of partial order relations? Let me tell you what is special with partial order relations, that they have one extra representation. For partial order relation, remember, for partial order relation we have another representation, that is hash diagram, and this is the most popular representation for partial order relations. So this is very important, that if you have a partial order relation, if you have a partial order relation R, then remember you can create hash diagram for this. You can create hash diagram. You can create hash diagram for this. Okay, hash diagram of R. And remember, if you have a hash diagram, if I give you a hash diagram, then it means, then it automatically means that your relation is partial order relation. Okay, relation is a partial order relation. So very simple point, I'm telling you that hash diagram is created only for partial order relation. For every partial order relation we can create hash diagram, and hash diagram is only created for partial order relation. Is this clear? So there is two way. Remember, partial order relation, for partial order relation you can create the hash diagram, and if you have hash diagram, then that means your relation is partial order relation. Okay, is this clear? Tell me, if your relation is not partial order relation, can you create the hash diagram? You cannot create hash, you cannot create. Okay, so hash diagram is created only and only for partial order relations. Very simple point. Now you already know that partial order relation is reflexive, antisymmetric, transitive. So always remember this. If I give you any partial order relation, then it will always be reflexive, antisymmetric and transitive. This we already know. Okay, now let's see how to create the hash diagram. What are the rules to create hash diagram? So these are the steps you can take to create hash diagram. In the hash diagram, remember, first you remove all the self loop. Means basically remove the self loops. It means, tell me, are you removing the reflexive property? Tell me, if I remove the self loop in the diagram, if I remove the self loop, am I telling you to remove the reflexive property? No, you cannot remove the reflexive property. We are just not showing the reflexive property. That is implicit. Okay, are you getting my point? For example, if I ask you what you have, okay, and you tell me that I have car, I have home, then tell me, will you tell me that you have pen? Okay, that is implicit, right? Yes or no? Of course you have pen. Okay, that is implicit. You are not showing it. You are not doing the show off. Okay, that is implicit. We are not showing it. So remember, in the hash diagram, we are not showing the reflexive property. So reflexive property we are making implicit. Okay, so very simple point. To create the hash diagram, remove all the self loop, remove the transitive edges, remove all the transitive edges. Okay, so don't show transitive edges. Again, remember, transitivity is implicit because every partial order relation is reflexive, transitive, and antisymmetric. So remember, in the hash diagram, in this diagram, we are not showing self loop, we are not showing transitive edges, but remember, implicitly, these things are always present. Okay, so very simple point how to create hash diagram. So remove all the self loop, remove all the transitive edges, and see this. Arrange all the edges to point in the upward direction. Okay, what it means? It simply means that if you have this edge A, A to B. Okay, what it means? If you have this edge, then in the hash diagram, how will you show it? In the hash diagram, in short, I will call it HD. Okay, this is what we are going to call it. So remember, this age we are going to show like this. Okay, upward direction. So just point it in the upward direction. Very simple point. So you can read this, that arrange all the edges to point in the upward direction. Okay, so remember, this edge you can point in the upward direction, and then you remove this direction. Okay, don't show the direction on edges. So very simple point, that if you have this edge in the graph representation, this is the simple graph representation, right? Okay, this is your simple graph representation. If you have this edge, then very simple, you can do like this. Okay, and what else you will do in the hash diagram? Don't show the self loop. So remove all the self loop, remove all the transitive edges, arrange all the edges to point in the upward direction, and remove this direction. Okay, this arrow, remove this arrow. So very simple point. Okay, this is how you can create. So this is how you can create the hash diagram. Don't show the self loop. Basically, reflexive property is implicit. Okay, we are not showing the reflexive property, but it is there. Okay, don't show the transitive edges. Basically, transitivity is also implicit. We are not putting the transitive edges, but implicitly these things are also present. Okay, remove all the directions on the edges, and all the directions are in the upward direction. Okay, is this clear? All directions are in the upward direction. Very simple point. Okay, so remember, in the hash diagram, if I give you a hash diagram, let's assume I'm giving you hash diagram, I'm giving you, you just focus on this A, B, C. Okay, consider this hash diagram. First of all, you tell me, if I'm telling you that this is hash diagram, so can I say your relation is partial order relation? If I'm telling you this is hash diagram, then it automatically means relation is partial order relation. Okay, because hash diagram is only created for partial order relations. Now, here you tell me some questions I am asking you. You tell me, let's assume you have relation R. Okay, this is hash diagram of relation R. Okay, this is a hash diagram of relation R. Then relation R is partial order relation. You tell me very simple point. Can I say that A is related to A? Is this true or false? A related to A. Yes, this statement is true, because remember, we are not showing in the hash diagram, we do not show the self loop, but they are implicitly present. Okay, we have, those are implicitly present. Can I say A is related to B? Yes, that is also true, because all the directions are upward. Remember, A is related to B. Can I say B is related to A? Can I say B is related to A? This is false, because all the directions are upward. A is related to B, A is related to C. But remember, B is not related to A. So remember, very simple point, B is not related to A. Okay, B, that is not related to A. Very simple point. Okay, and you tell me, can I say A is related to C? Yes, A is related to C. Okay, and what about C related to A? C is not related to A. Okay, because all the directions, remember, they are upward. Okay, assume that all the directions are upward. Very simple point. Can I say B is related to B? Yes, B is related to B. In the hash diagram, we do not show the reflexive property. In the hash diagram, we do not show the self loop, but reflexive property is always there. Every partial order relation is reflexive, antisymmetric, transitive. Okay, so similarly, C related to C is also there. Very simple. Okay, now let's see. Now we will construct the hash diagram for this For this partial order relation, we already know this less than equal to, this is a partial order relation on every set of numbers. So you can see this is a partial order relation. And for partial order relation, we can create a hash diagram. First, I will create the normal graph representation. Okay, what I will do, remember, I will create normal graph representation of R. Okay, so let me create. Very simple, 1, 2, 3, 4. Okay, you can see that 1 is less than equal to 1, 1 is less than equal to 2, 1 is less than equal to 3, 1 is less than equal to 4. 1 is related to everyone. 2 is related to 2, 2 is related to 3, 2 is related to 4, because your relation is less than equal to. You can see 3 is less than equal to 3, 3 is less than equal to 4, and finally I can say 4 is less than equal to 4. This is the normal graph representations. Okay, yes or no? Now, to create the hash diagram, I want to create the hash diagram. Then first, what I will remove, tell me what I'm going to remove first. If I want to create the hash diagram, then first I will remove self loops. Okay, yes or no? Remove all the self loops. So let's do that. If I remove all the self loops, then what I'm going to get? Okay, let me quickly draw. You can see 1 related to 1, sorry, 1 related to 2, 1 related to 3, 4. Okay, so like this is the structure that I will get if I remove all the self loops. Yes or no? Now, what I will do? What is the second thing that to do? Okay, remove transitive edges. Yes or no? Remove transitive edges. Okay, remove all the transitive edges. So you can see very simple point that 1 related to 2, 2 related to 3. So can I say this is a transitive edge? See, 1 is related to 2, 2 is related to 3. Can I say this 1 to 3? This is a transitive edge. Yes, this is a transitive edge. Yes or no? This is a transitive edge. Now what you do? Remove all the transitive edges. So very simple point that 1 will be related to 2. Okay. 2 will be related to 3. 2 will be related to 3. I can remove this edge. This edge is gone. This transitive edge is gone. Okay. Also remember 3 is related to 4. So 1 related to 3, 3 related to 4. Then this 1 related to 4. This is also transitive edge. Yes or no? Very simple. This is also transitive edge. I can say this edge is also transitive edge. Similarly, you can notice 2 related to 3, 3 related to 4. So this 2 to 4, this is also transitive edge. Okay, basically remove all the transitive edges. This is also transitive edge. Okay, so finally, this is the structure you will get if you remove all the transitive edge. Okay, now after removing all the transitive edges, remember what you did? You removed. So far, what we have done? We have removed self loops. Okay, and we have removed transitive edges. Okay, and once we remove all these transitive edges and self loops, this is the structure we are getting: 1 related to 2, 2 related to 3, 3 related to 4. Now what we need to do? Now what we need to do? We need to put all the edges in the upward direction. Every edge we will put in the upward direction. So this 1 will be related to 2. Every edge, put every edge in the upward direction. Put every edge in the upward direction. Okay, and now what you do? Now you remove these directions. Yes or no? Finally, what you do? Remove directions. So very simple. Put edges in upward. Yes or no? Put all edges upward. Now, okay, from here, what you do? From here, just remove directions. Okay, remove directions. Now, if you remove the directions, now on the next page, I will draw it on the next page. Okay, so on the next page, this is the drawing. Finally, I can say 1, 2, 3, 4, and our relation is less than equal to, this is the drawing we will get. 1 related to 2, 2 related to 3, 3 related to 4, and this is your final hash diagram. This is the final hash diagram of this POSET. Okay, final hash diagram of this POSET. Let me call it, for example, P. Final hash diagram of POSET P. Is this clear? Let me know. So very simple point. I'm just explaining you how to create the hash diagram. Okay, to create the hash diagram, these are very simple things. Remove all the self loops, remove all the transitive edges, put all the edges in the upward direction. Basically, arrange all the edges to point in the upward direction, and do not show the directions on the edges. These are the 4 things that you have to apply, and you will get your hash diagram. Okay, let me tell you, to create the hash diagram, you don't have to do all these things. We can directly create the hash diagram. That also I will tell you. But this is just for explanation purpose, that you have the graph representation. This is your partial order relation. First, you create the graph representation, remove all the self loop, remove all the transitive edges, and then what you do, put all the edges in the upward direction, and then finally remove all the directions. Then this is the hash diagram you will get. This is only for explanation purpose, but we can create the hash diagram directly. Okay, this direct construction we can do, I will tell you. Okay, so let's move on. Now, one thing I want to tell you, and this is a note, that in any POSET, reflexive, transitive, and these properties are always there. Yes or no? In any POSET, whatever POSET you take, then reflexive and transitive properties will always be present. But remember, in the hash diagram, we are not showing these properties. Okay, we are not showing, but these properties are implicitly present. Okay, we are not showing, but they are implicitly present. They are always present, but we are not showing. Okay, for example, take this hash diagram. Okay, this is, let's assume this is hash diagram of relation R. Okay, first of all, you tell me, can I say relation R is partial order relation? Yes, of course, this is partial order relation, because only for partial order relation we can create the hash diagram. Okay, so this is the partial order relation. Now you tell me, can I say A1 is related to whom? Just tell me A1 is related to whom. Let me know. A1 is related to whom? You can easily see A1 is related to A1. A1 is related to A2. So you can see A1 is related to whom? A1 is related to A2 because all the directions are upward. A1 related to A3. You can easily see A1 is related to A2. A2 is related to A4. And there is transitive property. Every partial order relation is transitive. So A1 is related to A4. Yes or no? Because remember, in the hash diagram, we do not show the transitive edges, but implicitly transitive property is there. A1 related to A2, A2 related to A4. So transitively, A1 is related to A4. So you can see A1 related to A4. Okay, next I can say A1 is related to A5. Same logic. A1 is related to A3. A3 is related to A5 because all the directions are upward. In the hash diagram, all the directions are in the upward direction. Now you can easily see in the hash diagram, we do not show the transitive edges, but implicitly transitive property is there. So you can see that A1 will be related to A5. Okay. Similarly, whom A2 is related to? A2 is related to A2. A2 is related to A4. Okay. Similarly, if I ask you, A3 is related to A3, A3 is related to A5. Yes or no? Next, A4 is related only to A4. A5 is related only to A5. Okay, is this clear? Please tell me. All the points, are they clear? So very simple point. This is how you can understand hash diagram. Now let's move on. Now tell me the answer for this question quickly. In the hash diagram of a POSET, A related to B, if and only if, when can I say A is related to B? Is it mandatory that there should be edge between A comma B in the hash diagram? I am asking, in the hash diagram, is it mandatory that there should be edge between A to B? Or can I have, there is a path from A to B in the upward direction? So first of all, let me tell you about edge versus path. Edge versus path. Okay. See, edge is direct connection. Edge, what is edge? Edge is direct connection. Okay, direct connection is edge. Now, what is a path? Path can be sequence of edges. Sequence of edges. Okay, one or more edges. So remember, very simple point, that if I give you, like for example, A, B, C, okay, and let's assume you have D. Now here easily one thing you can notice, that this is edge. Okay, this is edge, this is edge. Okay, but remember, every edge is a path also, because sequence of edges. So every edge is a path also, remember. Every edge is a path also. is a path also. Okay, but remember, path is a sequence of edges. Sequence of edges. For example, this is a sequence, this is a path. Okay, remember all the edges are in the upward direction, right? Yes or no? Every edge is in the upward direction. So here you can see that this is also a path. Okay, this edge is also a path. Even this is not a edge, but this is a path. Okay, look at this, look at this. Okay, so you can see this is a path, but this is not a edge. Okay, for example, this A to C, this is a path, but this is not a edge. Is this clear? Okay, so very simple point. You can see, look at this, this is a path. Okay, so this is how you can understand. Remember, edge is a direct connection, and what is a path? Path is sequence of edges, one or more edges, one or more edges. So very simple, every edge is also a path. Okay, now you tell me, in the hash diagram you can see A is related to B. If what should happen, then I can say there is a path from A to B in the upward direction. Okay, in this situation A will be related to B. For example, look at this hash diagram. Can I say 1 is related to 8? In this hash diagram, you tell me, can I say 1 is related to 8? Is this true? Yes, that is true. What is the reason? Because there is an upward path. Yes or no? We have upward path from, there is an upward path from 1 to 8. Yes or no? You can easily see this is the upward path because all the directions are upward. All the directions are upward. So I can say this is your upward path. Okay, is this clear? So I can say 1 is related to 8. Yes. Similarly, tell me, can I say 3? Can I say 3 is related to 4? Is this true? 3 is related to 4 or not? 3 is not related to 4 because from 3 to 4 there is no upward path. Is there any upward path from 3 to 4? Okay, because there is no upward path. There is no upward path from 3 to 4. Yes or no? Can you go from 3 to 4? If I want to go, can I go in the upward direction? You can only go in the upward direction. Remember, we can only go in the upward direction. So if I want to go from 3 to 4, you cannot go downwards because all the edges are upwards. Remember, every edge is upward. Okay, every edge is upward. So you can see, can I go from 3 to 4 in the upward direction? In the upward direction, I cannot go. Yes or no? So 3 is not related to 4. Tell me about this. Can I say 2 is related to 12? What about 2 related to 12? Yes, that 2 is related to 12. Yes or no? Because there is an upward path. Look at this. Okay, so there is an upward path. Let me show it that this is the upward path. Okay, from 2 to 12, you have upward path. Very simple. Is this clear? So 2 is related to 12 because we have, there is upward path. There is upward path from 2 to 12. Okay, so that is the reason. I hope you understood. So again, you tell me, can I say 3 is related to 12? Yes, 3 is related to 12 because there is upward path from 3 to 12. Yes or no? So 3 is related to 12. I hope you understood. What about 6 related to 6? Can I say 6 is related to 6? Yes, of course, 6 is related to 6 because hash diagram is created for partial order relation. Every partial order relation is reflexive. So I can say 6 is also related to 6. Okay, so very simple points. Now, so remember, in the hash diagram, all the edges are in the upward direction. This is the first point. There is no concept of horizontal edges. We have no concept of horizontal edges. You cannot have horizontal edges, remember. In the hash diagram, every edge is in the upward direction. A is related to B if and only if there is a upward direction path. There is a path from A to B in the upward direction. Okay, so these are the things that we have seen. Now, tell me the answer for this question. In a POSET, let A related to B, A comma B are different. A comma B are different. There is some element C which is different from A to B, which is different from A comma B. There is some element C such that A related to C, C related to B. Then can we have A's between A comma B? Can we have A's between A comma B in the hash diagram? Can we have A's between A comma B in the hash diagram? And the answer is clearly no. Because in the hash diagram, you cannot put transitive edges. See what the question is saying. The question is saying A is related to B. This is the given information, A related to B. A is not equal to B. This is given to you. And the question is saying that C is not same as A, C is not same as B. Okay, the question is saying that A related to C, C related to B, C related to B. So now you tell me, can we have age between A comma B? Can we have? So you can easily see we cannot have age between A comma B. Okay, between A comma B, we cannot have age. Why? Because now you can see this AB is transitive age, yes or no? This is a transitive age now. Please understand, now this is a transitive age because A related to C, C related to B. So this AB is, this is transitive age, and we don't show transitive age. Remember, in the hash diagram, we don't show transitive age in the hash diagram. Okay, don't show transitive age in the hash diagram. Don't shown in hash diagram. Is this question clear to everyone? What this question is asking? This type of theoretical question they can ask you. So remember, we will not have this age. This age will not be present, okay, in the hash diagram, because you can see that A is related to C, C is related to B. Okay, so this transitive age we do not show. Okay, we do not show this transitive age. Remember, I hope you understood. We don't show this. Okay, understood. Let me know. This question is clear to everyone, that you have a POSET A related to B, A comma B are different elements. There is some element C which is different from A comma B. Okay, such that A related to C, C related to B. Now you cannot show this age in the hash diagram between A comma B because that is transitive age. And in the hash diagram, we do not show transitive age. Tell me the answer for this question. Again, you have a POSET A is related to B, A is not equal to B. There is no element C. There is no element C different from A comma B. There is no element C such that A related to C, C related to B. Basically, between A comma B, remember the question is saying A is related to B and there is no one intermediate person. Okay, A is related to B and there is no intermediate person. There is no intermediate person. There is no intermediate person. There is no intermediate person other than A comma B. Yes or no? Other than A comma B, there is no intermediate person. Now you tell me, is it necessary that you will get this age AB? Is it necessary you will get it in the hash diagram? Is it necessary? Is it necessary that you will get age between A comma B? Yes, that will be necessary now. Okay, now that will be necessary. Yes or no? Is this clear? Now that is necessary because there is no intermediate person. So this age is not a transitive age. Is this clear? Okay, so I can say that this age, look at this age is not a transitive age. This is not a transitive age. Okay, this is not a transitive age. So that is the reason, remember what we will do? We will show it in the hash diagram. This age will definitely come. Yes or no? This is the age in hash diagram. Is this clear to everyone? Please tell me, can this be a self loop? This age, can it be a self loop? Is it possible this age can be a self loop? No, the question is saying A is not same as B. The question is saying A comma B are different. A comma B are different. So this is not a transitive age. This is not a self loop. Yes or no? Is this clear? This is not transitive age, comma, self loop. Okay, is this clear? So very simple, that necessarily in the hash diagram you will get this age. Now let's create the hash diagram for this structure. So tell me one thing, if I want to create hash diagram for this structure, for this partial order relation, will I create the graph representation, then remove the self loop, then remove the transitive edges, then put all the edges in the upward direction, and then remove the directions? Will I do that? Will I go like this? You don't have to go like this. Okay, that is a dumb method. You don't have to do that. You can create directly, direct construction. So let me tell you how to construct this hash diagram directly. Direct construction of hash diagram. These are the guidelines. Start from the bottom. Basically, always start from the element which is related to many elements. Okay, so remember, always start from the bottom. Next, read this statement, this second statement. Read this statement. If A related to B, B related to C, then will you put A's from A to C in the hash diagram? If A related to B, B related to C, then will you put A's from A to C in the hash diagram? No. Okay, then no A's from A to C. Yes or no? Okay, very simple. Agree. Else, otherwise you will put A's from A to C in the upward direction. Agree with me? Okay, very simple point. If A related to B, B related to C, then there is no A's from A to C. Okay, very simple. But otherwise we will put A's from A to C in the upward direction. So this is the guidelines for direct constructions. Very simple. Now let's use these guidelines. Okay, so this is your relation. Your relation is divides relation. This is the relation, divides relation. So first you tell me, if I start from the bottom, which element can I start with? Which element is related to most of the elements? Okay, which element divides most of the elements? For example, you can see that which element divides most of the elements. You can see that is 1. You can see that 1 divides 1, 1 divides 2. Yes or no? You can see 1 divides 3. Your relation is divided. So that is same as 1 divides 1. That is same as 1 divides 2. That is same as 1 related to 3. So very simple. So you can start from the bottom. That is 1. Okay. So let's start from the bottom. Okay. Remember 1 divides 4 also. And 1 divides 6 also. Yes or no? Okay. So 1 is related to 4 also. 1 is related to 6 also. Very simple. And you can easily see that 2 will be related to whom? 2 will be related to 2, 2 will be related to 4, 2 will be related to 6. Next, 3 will be related to 3, 3 will be related to 6. Okay, because 3 divides 3, 3 divides 6. And similarly, I can say that 4 is related only to 4 because 4 divides 4. And remember, at last, I can say 6 is related to 6 because 6 divides 6. Very simple. Now start from the bottom. So start from 1. You can see 1 is related to 2. Okay. Now you can see 2 is related to 4. Now you tell me, do I have to put this age 1 to 4? Will I put this age? No, because this is transitive age now. This 1 to 4, this is transitive age. So start from the bottom. 1, then 1 is done. Okay, 1 is done. Then 2 is done. Where to put 3? Can I put like this? Can I put like this? No, because remember 2 does not divide 3. 2 does not divide 3. Yes or no? You can easily see that 2 is not related to 3. Okay, so very simple. But 1 divides 3, so I can put 3 here. Now 3 is done. 4 is done because 2 divides 4. Now where to put 6? Please tell me where to put 6. You can see that 6 I will put here. 3 divides 6. Do I have to put this age? Is it necessary? Is it necessary to put this age? Is it necessary? Yes, this is necessary because this is not transitive. See, if I don't put this age, can 2 be related to 6? Is it possible 2 is related to 6? No, 2 is not related to 6 because there is no upward path from 2 to 6. So this age is also mandatory. And this is your final hash diagram. Is this clear? This is your hash diagram. Understood? So start from the bottom and just keep creating the hash diagram element by element. Okay, keep taking all the elements one by one and create the hash diagram. So these are the guidelines for direct construction. Start from the bottom. Okay, and this is your another guideline. Now, let's see this one. Take your copy pen. Take your copy pen and let's quickly do this. So construct the hash diagram for this POSET. Okay, again your relation is divides relation. So you can see you will start from the bottom, right? Yes or no? So start from the bottom. Let's start from 1 because 1 divides 1, 1 divides 2. Okay, now remember, please understand, this element is gone. This element is gone. This element is gone. Where to put 3? Just tell me where to put 3. You can see that I can put 3 here because remember, 2 is not related to 3. 3 is not related to 2. Yes or no? You can see that 3 does not divide 2 and 2 does not divide 3. So 2, 3 are incomparable. They are incomparable. Yes or no? They are actually incomparable. So this 3 is also done. Where to put 4? You can see 2 divides 4. But remember, they are incomparable. 3 comma 4 are incomparable. 3 does not divide 4 and 4 does not divide 3, so they are also incomparable. Now this element is gone. Where to put 6? Where to put 6? Remember, you can see that I will put 6 here. 3 divide 6, and I have to put this as also. Okay, I have to put, because if I don't put this as, if I don't put this as, then I cannot have upward path from 2 to 6. But remember, 2 divide 6. Okay, so I have to put this as also. Okay, so let me put this as. Now this 6 is gone. Where to put 7? Where to put 7? You can notice these elements, they do not divide 7. See, these elements, they do not divide 7. So 1 divides 7, so I can put 7 here. Now 7 is also done. Where to put 8? Who divides 8? Tell me, who divides 8? I can say that this 4 divides 8. Yes or no? 4 divides 8. You can see 6 does not divide 8. Okay, no problem. This also does not divide 8. So that's it. Okay, 4 divides 8. Now this 8 is also gone. What about 12? Who divides 12? Tell me, who divides 12? Very simple. 6 will divide 12. Okay, is this done? Is this done? No, 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 no. Remember, 4 also divides 12. 6 divides 12 and 4 also divides 12. Okay, now this is hash diagram. Now this is your final hash diagram. Is this clear? So this is how you can create the hash diagram. I hope you understood. Let's move on now. Let's create the hash diagram for this one. 1, 2, 3, 4, 5, 6, 7, 8. Let's quickly do this. Again, the relation is divides. Okay, always go step by step, one by one. Start from the bottom. You can see 1 is related to 2. Okay, so 1 is over, 2 is over. Where to put 3? Remember, 2 is not related to 3, but 1 is related to 3. 1 is related to 3. Next, where to put 4? You can see 2 is related to 4. So 4 is also done. Where to put 5? You can see these things are not related to 5. They do not divide 5. Okay, they do not divide 5. So I can say that 1 divides 5. So I can put 5 here. Next, where to put this 6? So you can see this 6 I can put here. 3 divides 6, 2 divides 6. Very simple. Then where to put 7? These people, they do not divide 7. Yes or no? They do not divide 7. They are not related to 7. So I can put 7. For example, I can put 7 here. Okay. And where to put 8? Where to put 8? You can see that 4 divides 8. Okay. 4 divides 8. That's it. So this is your hash diagram. Is this clear? Very simple point. Now let's move on. So we have created hash diagram. Now, what is the hash diagram for this quickly? Hash diagram for now, this is your relation. Your relation is less than equal to. So start from the bottom. You can see 1 is less than equal to 2, 1 is less than equal to 3, 1 is less than equal to 1, all these things. So start from the bottom. 1 is related to 2. 1 is done, 2 is done. Now where to put 3? You can notice 2 is related to 3. Okay, you can notice 3 is related to 4. So this is your hash diagram. That's it. Okay. Next, let's see this one. This is your relation. Your relation is what? Your relation is greater than equal to. Now you tell me, who will come in the bottom? Which element is greater than equal to most of the elements? Which element is related to? Now you can see 4 is related to 1 because 4 is greater than equal to 1. Okay, 4 is related to 2 because 4 is greater than equal to 2. 4 is related to 3 because 4 is greater than equal to 3. Yes or no? So remember, now your bottom element will be 4 because 4 is greater than equal to 3. 4 is related to 3. Okay, so this is your element. 4 is related to 3. Next, 3 is related to 2. 3 is related to 2 because 3 is greater than equal to 2. Okay, so 3 is related to 2 and 2 is related to 1. So this will be your hash diagram. Okay, so now your bottom element is, remember, 4. Now you will start with the 4. Now let's move on. Tell me the answer for this. Your relation is subset relation and your base set has how many elements? Tell me. Your base set has how many elements? In your base set, there are total 4 elements. Okay, these are subset of A, comma B. So your base set has these elements. Now tell me, you will start with which element? Your relation is subset. You can notice phi is subset of every set. Yes or no? Phi is related to everyone. Phi is related to A. Phi is related to AB also. Okay, so phi is subset of everyone, this phi. Okay, so this phi is done. Okay, this is done. Now you can see where to put this element. So you can see phi is subset of this element. Okay, what about this element? Tell me, are they comparable? These two elements, are they comparable? Can I say this element is subset of this? No. Also, can I say this B is subset of A? No. So they are incomparable, right? Okay, I can say they are incomparable. These elements are not comparable. So I can put here. Okay, I can put here phi is related to B. And finally, where to put this element? You can see this is also subset of AB and this is also subset of AB. So this is the design you will get. Is this clear? So this is your hash diagram. Very simple. Now let's move on. Now let's solve this question. Let's solve this question. Try to solve it. This is a very nice question, standard question. So this question is taken from this university. Let's quickly solve it. This set X is given to you. Okay, this is your base set. Is this clear? In this, every element is a set. Now, you are defining this relation. You are defining a relation. You are saying that U is related to V, where U, V are from the base set. This is your base set. Okay, and U is subset of V. So U is related to V if U is subset of V. Very simple point that this is your base set. Okay, is this clear? Tell me. Base set. 6% means you will get 6% marks. See, this question is taken from a midterm. Okay, from a test. So you will get 6% marks if you solve this question. Okay, out of 100, 6% marks, you will get 6 marks. So anyway, you can see this is your base set. Okay, in the base set, can you notice every element is a set? Okay, every element is a set. These are set. Now the question is saying you are defining a relation. You are saying that in your relation you have U comma V. Okay, in your relation you have U comma V. U is related to V, where U comma V are coming from X, because X is your base set. Okay, and you are saying that U is related to V if U is subset of V. So this is very simple, that U is related to V if and only if U is a subset of V. So your relation is subset. Is this clear? In simple words, I can say this is your subset relation. In simple words, this is how you can understand. Now the question is saying that create the hash diagram. First of all, you tell me subset relation, is this always a partial order relation? Subset relation, this subset relation, is it always a partial order relation? Yes, this is always a partial order relation if your base set contains set. You can see in your base set every element is a set. This is a set, this is a set, every element is a set. So remember, this subset, this is always a partial order relation. Okay, very simple. Now for partial order relation, you can create the hash diagram. So let's create the hash diagram now. Okay, let me create the hash diagram. So let's start with the bottom element. Tell me what will be the bottom element. I want to start with the bottom element. You can easily see that I can start with this. Okay, so let's start with A. Okay, let me start with A. So I am starting. Let me start with this element A. Now, this element is done. Now, this element is subset of AB. Yes or no? Okay, this element is subset of AB because I can say that this element is related to AB because your relation is basically subset. This is your relation subset. So I can say that this element is actually related to AB. Okay, so this age I can put. Okay, what about ABC? Where to put this ABC? Yes, this AB is related to ABC. Yes or no? This AB is related to ABC. Okay, what about this ABCD? Yes, this ABC is a subset of ABCD. Okay, yes or no? This ABC, this is subset of ABCD. So very simple point that this ABC, this is subset of what? This is subset of ABCD. Okay, so far everything is good. Yes or no? That you can see this element is related to this is related to this is related to this. Yes or no? Very simple. You can see this element is a subset of this element. This element is subset of this element. This element is subset of this element. So far, these 4 elements are gone. Okay, these are gone. Now, where to put AC? These elements, are they related to AC or AC is related to them? Tell me. Tell me. You can see that A is, see, these AC and AB, they are incomparable. But I can say A is subset of AC. Yes or no? A is a subset of AC. Now, one more thing, that AC will be related to ABC or not? AC will be related to ABC. Okay, so don't forget this. Do not forget this, because AC will be related to ABC, because AC is a subset of ABC. Now tell me, do I have to put this age? Do I have to put this age? Will I put this age? I don't need to put this age, because this is transitive age. This age is transitive age, because you can easily see that, okay, there is upward path. You have upward path. AC is related to ABC, ABC related to ABCD. So this age we don't have to put. Okay, don't put this age. Very simple. Now where to put CD? Where to put this CD? You can see that I can say that A is not related to CD, right? A is not related to CD. Okay, so I can put CD, for example, here. Let me put CD here. Okay, now you can see CD will be related to ABCD. Okay, CD will be related to ABCD. That's it. This is your hash diagram. Is this clear? Please tell me. Let me know. This is your hash diagram. Is this understood? Okay. Now, is there anyone who is thinking that this should be at the bottom level? Tell me, this CD, this should be at the bottom level. At the bottom level. No, there is no concept of bottom. Remember, there is no concept of bottom level. Level concept is not there. Okay, there is no concept of level. Remember, there is no concept of level. You don't have any concept of level. You can put it here, no problem. You can put it here, that is also no problem. If you want, you can put it here also. There is no problem. Okay. So I hope you understood this question. This was a good question, right? Actually, this is a good question. Let me tell you why. Because some students, they can miss some edges. For example, some students can miss this age. Some students can put this age. Okay. Some students can miss this age. Okay. Some students can put this age. So a lot of mistake can happen in this question. Okay. So ultimately, this is your hash diagram. Tell me, in the hash diagram, how many edges? In the hash diagram, how many edges? I am asking number of edges in the hash diagram. So you can easily see 1, 2, 3, 4, 5, 6. Total 6 edges are there. Okay. Very good. Now let's move on. Now let's create the hash diagram for subset relation on this set. Okay. On power set subset relation. So you can do that. Okay. So I'm not doing it. You can do it. This will be your hash diagram. You can do it. Okay. So remember, this is your question. You have subset relation. A is related to B. Okay. A is related to B. Remember, this actually means A is related to B. A is related to B. Okay. If and only if A is a subset of B. So you have a subset relation and your base set is your power set. So there will be total 8 elements and this will be your hash diagram. You can do it. Next, this is another very interesting question I'm giving you as a homework. See, one interesting question we have already seen, right? This was a beautiful question from this university. For this question, we have already created the hash diagram. This hash diagram we created. Now I'm giving you this another beautiful question as a homework. Okay. So this is a really good question. Understand this question and create the hash diagram. So please comment your answer in the comments. You can put your answer. Pause the video, solve this question, and write your answer in the comment. Okay. And video solution is available in the pinned comment. You can check it out. Okay. For video solution, just check the pinned comment. Now, let's solve this question also quickly. Construct the hash diagram for 3, 5, 3, 4, 5 and divides. Now you tell me, what will be the hash diagram? So let's start with 3. You can see 3 does not divide 4, 4 does not divide 3. So 3, 4, 5. This is your hash diagram. Is this correct? Tell me, is this correct? Yes, this hash diagram is correct. Okay, tell me. Is this hash diagram correct if I do like this? Is this hash diagram correct? If I do like this, is this hash diagram correct? Is there any violation here? Did I make any violation? No, there is no violation. This hash diagram is also correct. Because in the hash diagram, remember, oh, tell me, can I say 3 is related to 4? From here, tell me, can I say 3 is related to 4? No, 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 no. Remember, in the hash diagram, 3 will be related to 4 if there is a upward path. There is no upward path. From 3, can you go to 4? From 3, can you go to 4? Upward path. There is no upward path. So remember, this hash diagram is also correct. In the hash diagram, there is no concept of level. There is no concept of level. For example, this hash diagram, this is also correct, no problem. Okay, all these hash diagrams are same. Okay, but if you do this, now there is a problem. So this is the final point, that remember, there is no concept of level. In the hash diagram, don't use this word level. Don't use this word. There is no concept of level in the hash diagram. There are no horizontal edges. All edges are in the upward direction. A is related to B if and only if there is an upward path from A to B. Okay, let's move on now. Now let's see the next topic, that is finding set representation from hash diagram. If I give you the hash diagram, remember hash diagram is just a representation, right? Yes or no? For any partial order relation, you can create set representation, you can create hash diagram, you can create the normal graph representation, you can create the matrix representation, right? So remember, hash diagram, that is just a representation. This is just a very popular representation of partial order relation. But can you create from hash diagram, can you create set representation? This is the question. Okay, so let's see it. Now let me give you a hash diagram of relation R. Okay, I'm giving you, and this, consider this hash diagram: A related to B, A related to C, and C related to D. Okay, now tell me one thing. If I'm telling you this is a hash diagram, does it mean this relation is partial order relation? I'm telling you this is a hash diagram, so this relation will be partial order relation, because for partial order relation we create the hash diagram. Okay, we create the hash diagram only for partial order relation. So this is a partial order relation. Okay, now you tell me, if this is a partial order relation, can I say this is reflexive? Can I say this is transitive? And can I say this is antisymmetric? Yes, all these properties are there. So remember, every partial order relation is reflexive. Now I want to create the set representation. I want to create set representation. So tell me, can I say A is related to A? A is related to A? Yes, of course, because there is reflexive property. Every partial order relation is reflexive. Hash diagram is created for partial order relation. And remember, every partial order relation is reflexive. Please understand that in the hash diagram, we do not show the self loop, but implicitly reflexive property is available. Okay, so remember, A will be related to A. Very simple point. Next, all the directions are upward. You already know. So tell me, A is related to whom? A is related to B, because all the directions are upward. So A related to B, A related to C. Can I say A is related to D? Let me know. Yes, of course, there is upward path from A to D. So A is related to D also. Okay, very simple. Very simple point. This is your transitive edge. You can see A related to C, C related to D, and transitively A is related to D. So very simple. Next, okay, remember A is related to D. Next, you can see B is related to whom? B is related to only B. C is related to whom? That is only related to C is related to C, C related to D. And D is related to only D. Okay. Now tell me two different questions I am asking you. I am asking you two different questions. Okay. Tell me the answer for these two different questions. If I ask you number of edges in hash diagram, what that will be? Number of edges in hash diagram, what that will be? That answer will be 3, because you have 3 edges, 1 edge, 2 edge, 3 edge. That answer will be 3. Another question I'm asking you, that is cardinality of relation R. What is the cardinality of relation R? Cardinality, I am asking, of relation R. Cardinality of relation R, that will be how many elements are there in R. Because relation is a set. Every relation is a set. In this relation, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 elements are there. So I can say cardinality of relation R will be 8. Okay, understood? Please tell me. Very simple. Now let's see. You have this hash diagram. A student is saying 2 power number of edges. Is that correct? No, that is not correct. You will see this here. Okay, that is not correct. Don't say 2 power number of edges. Okay, let's see this one. This hash diagram is given to you. This is hash diagram of relation R. Now you tell me what will be the cardinality of R. I am only asking you the cardinality of R. Because remember, this R is a partial order relation that you already know. This R is partial order relation. Okay. Now, every partial order relation is reflexive, transitive, and antisymmetric. So, okay, I'm asking you cardinality of R. This is what I'm asking you. Let me tell you, you don't have to create the set representation. You can directly do this. See, directly do this. Okay, tell me. How many this type of pairs will be there in R? Like if I create in this relation R, how many this type of pairs will be there? A1 comma something something. A1 comma something something. How many this type of pairs will be there? A1 is related to how many elements? Tell me. See, A1 is related to A1, A1 related to A2, A2, A1 related to A3, A1 related to A4, A1 related to A5. So A1 is actually related to 5 elements. Yes or no? 5 such ordered pairs will be there. Agree with me? 5 such 5 such ordered pairs. Do you agree? Okay, so there will be 5 ordered pairs where the first element is A. Where the first element is A. Now tell me, this type of how many ordered pairs will be there? Okay, where first element is A2. How many this type of ordered pairs will be there? How many this type? So you can see A2 is related to A2, A2 related to A4. So there will be 2 such ordered pairs. Okay, we will have 2 such ordered pairs. So very simple, 5, 2. What about this type? A3 something something. How many this type? How many this type? So again, there will be 2. Okay, A3 related to A3, A3 related to A5. So there will be 2 pairs. What about A4? How many this type of? Okay, A4 something something. How many this type of things are there? Only one. Only one pair. Okay, and tell me, how many this type of? A5 something something. Okay, how many this type of? Again, only one pair because A5 related to A5. So finally tell me, what the cardinality of relation are? Now what the answer will be? Tell me the cardinality of relation R. This answer. So cardinality of R, what that will be? So you can see 5 ordered pairs which start with A1, 2 ordered pairs start with A2, 2 ordered pairs start with A3, 1 ordered pair start with A4, 1 ordered pair start with A5. So 5, 2, 2, 9, 9 and 2, 11. One more thing, all these ordered pairs, can I say they are different? How can you say that they are different? All these ordered pairs, like these 5 ordered pairs and these 2 ordered pairs, can they have something common? Can they have something common? No, they cannot have something common because in here we are starting with A1, here we are starting with A2. So they are different. These ordered pairs are starting with A1. These ordered pairs are starting with A2. So they are different. So finally your answer will be 11 only. Is this clear? Okay. So very simple. Like this they can ask you. This is your Kenneth Rosen question. So let's solve it quickly. For example, for this partial order relation, for this hash diagram, can you create the set representation? Only for the first part, I will create the set representation. So this is your hash diagram. This is your hash diagram of relation R. Okay, let me call it R1. So this R1. Now let's create the set representation. You can see A will be related to A will be related to B, A will be related to C because there is upward path from A to C. Yes or no? A will be related to D also. Okay, remember A will be related to D because there is upward path. All the edges are in the upward direction, right? Okay, they are in the upward direction. So there is a upward path. So very simple point that A related to all these. Now, similarly, I can say that B is related to B, B related to C, B related to D. And finally, I can say C related to C, D related to D. This will be the set representation. Okay. So tell me, what is the cardinality of R1? If I ask you what is the size of R1, so you can see that will be 9. Okay. That is going to be 9. Yes or no? Actually, there is another way to calculate. If the question is interested only in the cardinality of R1, how many ordered pairs R1 has? R1 has how many ordered pairs? Can you directly count it? Yes. How many this type of ordered pairs are there? Which start with A. How many this? You can see A related to A related to B, A related to C, A related to D. So there will be 4 such pairs. Okay. What about this? Who start with B? How many such ordered pairs you have? This type of how many ordered pairs we have? You can see B related to B, B related to D, B related to C. So there are 3 pairs. Okay. Now you can see how many this type of pairs you have, which start with C, which basically C is related to whom? So you can see C related to C. So there is only one pair of this type. And finally, I can say D related to someone, this type of only one pair, because D is related to D. So finally, you have 4, 3, 1, 1. Your answer is going to be 9. Okay. Like this, you can do. Quickly, can you tell me what the cardinality of relation R2? Tell me quickly what is the cardinality of relation R2? Let me call this relation R2. You just quickly tell me the cardinality here. This cardinality of R1 is 9. Now you tell me the cardinality of R2. So because of A, how many? Because of A, there will be 5. Yes or no? 5 because of A. Means A related to A related to B, A related to C, A related to D, A related to E. Okay, so because of A, there will be 5. Because of B, there will be 3. Because of C, there will be how many? There will be 2. Because of E, there will be 1. And because of D, there will be 1. Okay, is this clear? So very simple. Your final answer, that is going to be 12. Yes or no? Very simple. Okay, tell me about the cardinality here. What is the cardinality of R3? What that will be? Okay, very simple. Because of C, how many? Because of C, what value you will get? You can see C is related to G. C is related to F, E, D. So C is related to C also. So because of C, there will be 5 pairs. There will be 5 pairs where C is related to someone. Okay, correct. Understood. Very simple. You tell me about B. Again, B will have 5 pairs. Yes or no? A will have 5 pairs. Okay. What about G? G will have how many pairs? That will have 4 pairs because G is related to G, G related to F, G related to E, G related to D. Okay. So because of G, there will be 4 pairs. Because of F, there will be 1, there will be 1, there will be 1. Okay. Because of F, E, D. So your final answer is what? So I can say that R3 relation cardinality, that is 5, 5, 5, that is 15, and 5, that is ultimately that will be 22. Okay, your answer is going to be 22. Is this clear? So this type of questions you can easily handle, right? This is another partial order relation. What is the cardinality of this relation? I'm giving you as a homework. Okay, let's take this as a homework. So this is your hash diagram of relation R. So automatically relation R will be partial order relation. Okay, so I'm giving you this question as a homework. Please comment your answer. Okay, there are two things you have to answer. How many edges are there in the hash diagram? In this hash diagram, how many edges will be there? Also, what is the cardinality of relation R? Okay, so these things you have to answer. Okay, you can write your answer in the comments. I will tell you whether it is correct or not. I will reply, don't worry. Let's see this question. This question is taken from this university. Let's quickly solve it. Is the diagram hash diagram? The question is asking two diagrams are given to you. Are they hash diagram? The question is saying two diagrams are given to you. Are they hash diagram? Are they hash diagram of a partial order? Is this hash diagram of a partial order? This is not a hash diagram, right? Yes or no? This is not a hash diagram. Why? Because horizontal edge. Yes or no? Because of horizontal edge. Because of horizontal edge. Tell me, what is the problem with horizontal edge? Can you tell me why horizontal edge is not allowed? Why horizontal edge is not allowed in the hash diagram? Because the problem is, now we cannot say whether D is related to E or E related to D. Yes or no? Now we can't determine. Now we can't determine. Now we can't determine whether D is related to E, whether D is related to E or E related to D. Yes or no? E related to D. Is this clear? So we cannot determine what is happening. Can both happen? Can I say both will happen? Okay, can I say D is related to E, E is related to D? Can I say both will happen? Both will happen. Both cannot happen because partial order relation is antisymmetric. Partial order relation is antisymmetric. Is antisymmetric. Because of this antisymmetric property, we don't have horizontal edges. So if someone asks you why no horizontal edges in the hash diagram, what your answer will be? Why no horizontal edges in hash diagram? Because of which property? Okay, because of, the answer is because of antisymmetric property. Due to antisymmetric property of partial order relation. Okay, is this clear? Very simple. Now, so you can see this is not a hash diagram. Remember, this is not a hash diagram. Very simple point. What about this one? Is this a hash diagram? Yes, of course, this is a hash diagram. There is no problem here. This is definitely a hash diagram. Okay, everything is fine here. Now, let's find out the cardinality of relation. Okay, for this one, means I am asking what the cardinality of relation are. So let's assume this is hash diagram of relation R. Let me call it hash diagram of partial order relation R. Now you tell me the cardinality of R. What that will be? I want cardinality of R. Okay. So again, very simple. Just quickly do this. How many this type of pairs? Just tell me the answer. How many this type of pairs? Only one pair will be there. A is related to A. Yes or no? Only one pair. A is only related to A, nothing else. Okay, how many this type of pairs? B is related to someone. How many this type of pairs are there? You can see B related to B, B related to C. Okay, upward path. Just look at upward path. Okay, just look at upward path. So this is what B is related to. Yes or no? Is this clear? So B is related. Can I say B is related to D? Do you have upward path from B to D? From B to D, do you have upward path? No, we don't have. Yes or no? We don't have. So very simple point that because of B, 6 will come. Okay, 6 pairs are coming because of B. 6. Okay, I am writing 6 pairs. Because of B, these 6 pairs are coming. Okay, so these are the B pairs. Okay, now, so 6. Now you tell me the next. How many C something pairs? How many this type of pairs will be there? Which start with C. Okay, there will be only one pair. C is related to C. That's it. Nothing else. Okay, how many this type of pairs will be there? D something pairs. So you can see D is related to D, D related to I. That's it. So there will be two. How many this type of pairs? How many pairs of this type? E related to E, E related to H, E related to I. So there will be 3 pairs of this type. Next, how many this type of pairs? How many this type of pairs are there? You can see F related to F, F related to I. So there are 2 pairs of this type. Okay, what about G? Okay, how many this type of pairs? G something pairs. How many? So G related to G, G related to I. So that will be 2. And finally, how many I? Okay, so there is H comma I also. So how many these? H. Okay, so that will be 2. And I, that will be 1. Is this clear? A, B, C, D, E, F, G, H, I. So we have covered all of them. Now you tell me the total. Okay, now you tell me the total. What is the final answer? Please tell me. Total is 20, right? Okay, so you can see this is your answer. Is this clear? You can just add all of them. That will be your answer. 20 ordered pairs are there in this relation R. The question can ask you how many ordered pairs are there in the relation R. So that will be 20 ordered pairs. Remember one thing, relation cardinality for any relation R. For any relation R, remember that relation cardinality, that means cardinality of relation R. What is that? That is number of ordered pairs in R. Okay, is this clear? So the question can ask you how many ordered pairs are in R. So that is the answer. Cardinality of R. Okay, for a particular relation, what is the cardinality? Cardinality means number of elements in R. Yes or no? Every relation is a set. Yes or no? If you look at any relation is a set which contains ordered pairs. Okay, which contains ordered pairs, right? Okay, every relation is a set where every element is a ordered pair. Okay, so every relation is a set. So I can ask you the cardinality of R, that is number of ordered pairs in R. Okay, this question you can take as homework. This is another question from a university. Okay, so in this question all you have to find, just find the cardinality of R1, find cardinality of R2, and find cardinality of R3. Okay, so can I give you this as a homework? Yes, please take this question as a homework. Write your answer in the comment. Pause the video, try to solve this question. Write your answer in the comment immediately. Okay, and the video solution is available in the pinned comment. You can check it out. One more thing, that for every homework question you can write a different comment. Okay, for example, at this moment you can pause the video and you can write a comment only for this question. Okay, for the previous homework question also you can pause the video, you can solve the question, write your answer in the comment. Okay, so for every question you can write a separate comment, you can write. Okay, now let's see the next topic, that is special elements in POSET. There are some special type of elements that we will discuss. So these are maximal element, minimal element, greatest element, and least element. Okay, these are special elements of a POSET. Okay, I want to tell you one thing. If you want to solve any question based on these elements, all you have to do, just apply the definition. Okay, very, very, very honestly, I'm telling you that many students, they do not understand the definition, or I can say they understand the definition but they do not apply the definition. So again I'm telling you, if you want to solve any question based on these elements, then best way is just understand and apply the definition. I'm giving you the definition, read the definition and apply the definition. Okay, let's see one by one. What are these elements? Maximal element, this element says that maximal element is an element which says that I am not related to anyone. Okay, I am not related to anyone, I am the boss, I am not related to anyone. Minimal says that no one is related to me. Okay, so you can see maximal says no one is above me, minimal says no one is below me. Okay, greatest element says everyone is related to me, everyone bows to me. Okay, least element says that I am related to everyone. Okay, is this clear? So these are the four type of elements. We will see the difference also, but these are the four type of elements. Let's see one by one. First, we will see maximal element. Maximal element says that I am not related to anyone else. Tell me, will it be related to itself? Will it be related to itself? Yes, of course. In a partial order relation, there is reflexive property. There is reflexive property. So remember, every element will be related to itself, but this maximal element is saying that I am not related to anyone else. Okay, so when can I say that this element M belonging to base set, when can I say this is maximal? What is the definition? This is maximal if and only if. What is the definition? Definition is very simple, that for all elements other than M, for all elements other than M, I can say that M is not related to B. Basically, maximal element says that I am not related to anyone. Is this clear? What maximal says? Maximal says that, let me create the diagram. Maximal element says that I am not related to anyone else. Okay, I am the boss. I am not related to anyone else. Is this clear? Please tell me. Okay, I am not related to anyone else. Okay, there is no one above me. There is no one above me. Very simple. Okay, this is the maximal element. What is the minimal element? Minimal element says that no one else is related to me. Okay, so again, M belonging to A. Now, when can I say M is minimal? M is minimal if and only if I can say that for all elements other than this small m. What I can say? I can say that no one is related to means B is not related to M. Is this clear? So minimal element, what it says that minimal element says that no one else is related to me. No one else is related to me. Is this clear? No one else is related to me. Now, let's see the next. That is greatest element. This is God. Okay, greatest element. This says that everyone bows to me. Okay, everyone is related to me. So remember, greatest element is like this. Okay, G. This greatest element, this is also called maximum. Okay, greatest, you can call it greatest, or you can call it maximum. This is maximum. So remember, when can I say G belonging to A? G is greatest. G is greatest if and only if it says that everyone is related to me. Okay, for everyone I can say, for everyone in the base set. Okay, everyone is related to me. Is this clear? So what greatest element says? The greatest element G. This says that everyone is related to me. Everyone is related to me. Okay, remember everyone. Next, let's see the least element. What the least element says? Again, the least element, this is also called minimum. Minimum. So when can I say this L belonging to A? When can I say L is least? If and only if least element says that I am related to everyone. Okay, I am related to everyone. For every element, I can say that I am related to everyone. L is related to B. Okay, so what is the diagram to understand least element? Least element says that I am related to everyone. Okay, is this clear? Please tell me. So I'm making all these elements here. Okay, just understand the this diagram. What is maximal? Maximal says that no one is above me. Means I am not related to anyone else. I am not related to anyone else. What minimal says? What minimal says? Minimal says that no one else is related to me. No one else is related to me. What greatest says? Tell me. What greatest says? Greatest says that everyone is related to me. Everyone is related to me. And what least element says? Least element says that I am related to everyone. Okay, understood? So these are the definitions. Now, one thing I want to tell you, just apply these definitions. Okay, greatest says that everyone is related to me. Least says that I am related to everyone. Minimal says that no one else is related to me. Maximal says that I am not related to anyone else. Okay, just apply these definitions in this question. What are the maximal elements? Tell me quickly. This hash diagram is given to you. What elements are the maximal elements? Maximal elements. So tell me. Maximal, remember the definition. Maximal means I am not related to anyone. Okay, I am not related to anyone else. This is maximal. So, who is saying that I am not related to anyone else? You can see L is not related to anyone else. M is not related to anyone else. Is there anyone else? Is this maximal? Is this maximal? No, this is related to M. Okay. Is this maximal? No, this is related to these elements. So, very simple point. These are the maximal. Who are the minimal elements? Okay, tell me who are the minimal? Remember the definition of minimal. What minimal says? Minimal says that no one else is related to me. No one else is related to me. So tell me, who are the minimal elements? You can see no one else is related to A. Okay. No one else is related to B. No one else is related to C. So ABC. Yes or no? And who is the greatest? Who is the greatest? Who is the greatest element? Is there any greatest element here? Can I say this is the greatest? This is the greatest. Why this is not greatest? Tell me why this is not greatest? Because greatest element says that everyone is related to me. Yes or no? Everyone is related to me. But you can see L is not related to M. Yes or no? L is not related to M. So I can say similarly, this is not greatest because greatest says that everyone is related to me, but M is not related to L. So there is no greatest. Yes or no? I can say does not exist. Okay, does not exist. What about the least element? Tell me about the least element. Again, that also does not exist because least element says that I am related to everyone. Is there anyone? Can I say this is least? Can I say this is least? Least element says that I am related to everyone, but this is not related to B. Yes or no? Similarly, this is not related to A. Similarly, this is not related to B. So there is no least element here because least element says that I am related to everyone. Okay, is this clear? Please tell me. Just apply the definition. Just apply these definitions. You have to apply nothing else. Okay. Tell me the answer for this question very quickly. This POSET hash diagram is given to you. All minimal elements. So what are the minimal elements? Remember minimal. Minimal element means no one else is related to me. Okay. So minimal elements are, I can say A is minimal element, B is minimal element. That's it. These are the A comma B. These are the minimal elements. What are the least element? What is the least element? Least element says that I am related to everyone. Okay. Can I say this is least? This is not least because this is not related to B. Can I say this is least? This is not least because this is not related to A. So very simple. This does not exist. Yes or no? Least element does not exist. What are the maximal element? Okay. What are the maximal? Maximal means I am not related to anyone else. Okay, so what is the maximal element here? I can say I, that is the maximal element. There is no other element. Okay, who is the greatest element? Greatest, what greatest means? Greatest means everyone is related to me. Everyone is related to me. So can I say everyone is related to I? Yes, A related to I. There is a upward path. B related to I, upward path. Yes or no? There is upward path from every element to I. So I can say this is greatest also. Okay, is this clear? This is greatest also. Very simple point. Okay, let's move on now. Tell me the answer here. What are the minimal? Quickly. I am writing the answer. The minimal element is no one else is related to me. So I can say A is minimal, D is minimal. Okay, that's it. These elements are minimal. Who are the maximal elements? I am not related to anyone else. H is maximal, G is maximal. Okay, only these elements are maximal. Yes or no? H comma G. F is not maximal. F is not maximal. F is related to H. F is related to H. F is related to H. So F is not maximal. Okay. So these are maximal. Who is the greatest? Greatest means everyone is related to me. So tell me, greatest. No, there is no greatest, does not exist. Okay. See, this is not greatest. Why? Because G is not related to H. This is not greatest. Why? Because H is not related to G. Okay. So there is no greatest element. What about the least element? What about the least element? That also does not exist. Least element means I am related to everyone. This is not least because this is not related to A. This is not least because this is not related to D. So least element also does not exist. Okay. Let's move on now. This question, can I give you as a homework? Please take this question as a homework. Write your answer in the comments. So pause the video right now. Try to solve this question and write your answer in the comments right now. Okay. For every homework, please make a separate comment. Okay. So pause the video, solve this question, write your answer in the comments. Okay. Here also you can easily see this POSET is given to you. This hash diagram is given to you. Minimal elements are AB. You can see maximal elements are CD, and there is no greatest element. There is no least element. There is no maximum or maximal, maximum or minimum. Maximum, minimum. There is no maximum, minimum. Tell me the answer for this question. Have you seen there is a movie King versus Kong versus Godzilla? There is a movie actually that is Kong versus Godzilla. Okay, so this dialogue is there in this movie. Okay, in this movie, this dialogue is there. Kong bows to no one. So who is this Kong? Maximal, minimal, greatest, or least? Can I say he's greatest? Can I say that Kong bows to no one? Can I say he's the greatest? Can I say? No, this is maximal. What is Kong in this dialogue? And your answer is maximal. Maximal. Because remember, Kong bows to no one means Kong is not related to anyone. Are you getting my point? Kong bows to no one. Kong bows to no one. Okay, greatest means what? Okay, when this will be greatest, when this Kong will be greatest, greatest means everyone bows to me. Yes or no? Everyone bows to me. Is this clear? See, Kong bows to no one. That is a choice of Kong. Yes or no? Agree with me? That is a choice of Kong, that Kong bows to no one. There are many people in the world, okay, who will speak this dialogue. Yes or no? But greatest means what? Greatest means everyone bows to me. Everyone is related to me. That is greatest. So in this dialogue, remember, Kong is maximal, not greatest. Okay, not greatest. Is this clear? See, look at these two dialogues and tell me which dialogue is more powerful. Which dialogue is more powerful? Everyone bows to me, I bow to no one. So here actually this is more powerful. This is the dialogue of greatest. And this is the dialogue of maximal. Actually, the second dialogue, everyone can speak this. Okay, nowadays I can say all the unemployed people on Instagram, okay, on the Facebook, okay, they will say, they will write in the bio, in the Instagram bio, okay, I bow to no one. Maybe yes or no? Yes or no? Agree with me? See, this is just like everyone can speak. Okay, nowadays, okay, all the Instagram unemployed people, okay, they can speak it. But this is very powerful. Everyone bows to me. Okay, yes or no? Everyone bows to me. Is this clear? Please tell me. So very simple. Remember, this is like a this is like a local local gunda type. Okay, local gunda. Yes or no? In the movies also you can see that the local gunda, he will say that I bow to no one. Yes or no? So Durjan Singh किसी के आगे नहीं झुकता. Yes or no? Chapri. Yes. Okay, so this is like a local gunda. This I bow to no one. Okay, everyone is nowadays a local gunda. Okay, so you can see. But this everyone bows to me. This is the dialogue of whom? This is the dialogue of God. Yes or no? This is the dialogue of God. Is this clear? So remember, very simple point. Okay, so now let's see this one. What is Pushpa by this dialogue? In the Pushpa movie, there is a dialogue, मैं झुकेगा नहीं. So what is Pushpa here? What is Pushpa here? Maximum, maximal, greatest or maximal? So here Pushpa is maximal, not greatest, not greatest. Yes or no? Because greatest means everyone bows to me. Yes or no? So that is the point. So here remember, here Pushpa is maximal. So next time, whenever you are discussing this Pushpa movie, then you can do some technical discussion. Okay, you can say that from this movie we can learn that this Pushpa is a maximal element in this world, which is a partial order relation, and he is a maximal element. This is not a greatest element because you can see this is the dialogue of maximal. Okay, so this type of discussion you can speak. Okay, and then your friends, they will throw you out, so they will not talk to you anyway. Now let's move on. So very simple. Now let's solve this question. Actually, for this question, if you remember, we have created the hash diagram. Do you remember this question? This beautiful question we have already taken. This is your base set and subset relation we are defining. We have already created the hash diagram. So this part actually we have done. Now what you have to do, you can take this as a homework, that what are the maximal, minimal, minimum, maximum elements. This is your homework. Okay, is this clear? So again, immediately pause the video, try to solve this question. First you create the hash diagram. This we have already created, but you can again create the hash diagram, find minimal, minimum, maximal, maximum elements, write your answer in the comment. Video solution is available in the pinned comment. Tell me the answer for this question. In a POSET, can we have more than one maximal elements? Tell me. In a POSET, can you have more than one maximal elements? Maximal. Yes, more than one maximal elements can be there. Yes or no? Okay. In a POSET, we can have more than one maximal element. Okay, we can have more than one maximal elements, we can have more than one minimal elements. So these things we can have, right? Okay, but tell me, how many greatest element can we have? See, maximal, this is like a local gunda. Okay, I bow to no one. So you can have many local gundas. Yes or no? No local villains. Similarly, you can have more than one minimal elements. So far, in many examples, we have already seen. But what about the greatest? What about the greatest? See, greatest, either it will not exist. See, please understand, either it will not exist, or it will be unique if exist. Okay, either it will not exist or it will be unique. Okay, is this clear? If exist, it will be unique. Similarly, list element in all the examples we have seen that either it will not exist, or if it exists, then it will be unique. Okay, is this clear? So remember, maximal, minimal, if they exist, they will be unique. Sorry, least and greatest means maximum, minimum. Okay, so you can see minimum, maximum, least and greatest element, they are unique if they exist. Okay, either they will not exist, if they exist, they will be unique. Actually, the proof is very interesting. This is a summary lecture, so I should not do the proof, but the proof is actually very interesting. You just have to apply your definition. Okay, let's quickly do this. So this is a question that can we have more than one greatest element? Can we have more than one greatest elements? Tell me, can we have more than one greatest elements in a POSET, in any POSET? Okay. The answer is no. The answer is no. And the proof is actually very simple. Assume you have for contradiction. Okay. Prove by contradiction. Just assume for a moment, you assume that you have two different elements greatest. Okay. For by contradiction. Okay. Assume, just assume that A comma B are greatest. Okay. Assume A comma B are greatest and A is not equal to B. Is this clear? Okay, assume for a moment, assume that you have more than one greatest element. Is this clear? For a moment, assume that you have more than one greatest element. Assume A comma B are greatest they are they are different. Now, by the definition of greatest, what will happen? By the definition of greatest, just apply the definition of greatest. A comma B are greatest, right? Yes or no? So what that means? By the definition of greatest, A is greatest. What that means? Everyone is related to A. Yes or no? A is greatest means everyone is related to A. B is greatest means everyone is related to B. Okay, remember. So remember, everyone is related to A. So can I say B will be related to A? Yes or no? Yes. Similarly, everyone is related to B. Everyone is related to B. So A is related to B. See, they are different elements and you are getting this situation. So where is the contradiction? Did you get a contradiction? See, can you see the contradiction? Where is the contradiction? The contradiction is antisymmetric property is violated. Yes or no? POSET is antisymmetric. Every POSET is antisymmetric. You are violating the antisymmetric property. Okay, look at this. Antisymmetric property violated. This is your contradiction. And why this is a contradiction? Because antisymmetric property violated. So it means what? If you are getting a contradiction, what that means? If you are getting a contradiction, it means your assumption is wrong. It means your assumption is wrong. It means you cannot have more than one greatest element. Yes or no? We cannot have more than one greatest element. Is this clear? Please tell me. Let me know. So very simple proof, right? In the proof, did you notice what we are using? We are using the definition only. We are using the definition of POSET. POSET is antisymmetric. We are using the definition of greatest. Element is greatest if everyone is related to it. Greatest element means everyone is related to it. So if you assume A is greatest, then everyone will be related to A. So B will be related to A. If you assume B is greatest, then everyone will be related to B. So A will be related to B. Now, A comma B are different and you are getting this A related to B, B related to A. So that is antisymmetric property violation. So that is the contradiction. So our assumption is wrong. It means we cannot have more than one greatest element. Okay. So very simple point. I hope you understood. And read these points also. These are some easy points. Can I say every list element is minimal? Tell me, simple point. Can I say every list element is minimal? Every list element is minimal. If you have a list element, then that is minimal also. Yes, of course. Okay. Can I say minimal element is list element? No. Okay. No. Yes or no? Similarly, remember the greatest element will be maximal also. The greatest element will be maximal also. Okay. And you can see, but this does not happen. Okay. So very simple, these points. If A is if A is least element, then A is minimal also. If B is greatest element, then it is maximal also. Okay, you can notice. If you have more than one minimal element, can you have least element? If you have more than one minimal element, if you have more than one minimal element, can you have least element? You cannot have least element. Okay, if you have more than one minimal element, then we cannot have least element. If you have more than one maximal element, then we cannot have greatest element. Okay, so these are some easy points, very simple points. Now let's see this question. Tell me the answer for this one quickly. In a POSET, X is maximal element. If X is maximal element, then how many elements B are there to which X will be related? See, X is maximal. I am asking how many elements are there to which X will be related. See, X is maximal, means X is not related to anyone else. So, how many elements are there to which X will be related? The answer will be 1. Don't forget the reflexive property. X will be related to X. Yes or no? Don't forget the reflexive property. Do not forget about the reflexive property. Every partial order relation is a reflexive, transitive, antisymmetric. Okay, so if you are thinking that answer is 0, remember in the maximal we say that it is not related to anyone else. It is not related to anyone else. But of course it is related to itself. So the answer will be 1. Tell me the answer for this question. If X is minimal, if X is minimal, means no one else is related to X. Okay. Then how many elements are there who are related to X? Again, the answer will be 1 because X will be related to X. Okay. Let's see the next question. Tell me the answer for this question. What should I write here? X is what kind of element? If and only if this happens, then B will be X. Okay. If this happens, if B is related to X, then B is X. So tell me here, what should I write in this blank? In this blank, what should I write? Tell me. Whose definition is this? Basically, we are saying that if B is related to X, then B is X. Means only X can be related to X. Yes, this is the definition of minimal. Okay. Actually, if you notice the definition of minimal, what is that? See, look at the definition of minimal element. Minimal element says that M is minimal if and only if. Okay. For all elements, what you can say? For all elements in the base set, I can say that if B is not equal to M, then tell me what will happen. Tell me what will happen. If B is not equal to M, then tell me what will happen. Then B will not be related to M. Yes or no? Then B will not be related to M. Agree? This is the definition of minimal, that no one else is related to me. So for all elements, you can say if it is not same as M, then B is not related to M. Now tell me, can you see what will be the contrapositive? What will be the contrapositive? Just write the contrapositive. What that will be? Okay, this implication statement, this is equivalent to its contrapositive. So the contrapositive you can write that will be, for all elements I can say that, for all elements I can say, if B is related to M, then B is M. Okay, if B is related to M, then B is M. So this is the definition of minimal. If B is related to X, then B is X. What this means? See, understand this. We are saying that X is what kind of element? If whenever someone is related to X, whenever someone is related to X, then B is X. It means no one else is relating to else X. Okay, so that is the definition of minimal. I hope you understood. So in the GATE exam, this type of question also they can ask. Okay, they are twisting the definition. Did you notice? This definition we have already seen, but you can write the contrapositive. In the GATE exam, they can write the contrapositive. Is this clear? Please tell me. Now tell me the answer for this question. X is what kind of element? If and only if. Whenever X is related to B, then B is X. Whenever X is related to B, then B is X. So very simple, that is maximal. Okay, again the same thing. What is the definition of maximal? See, maximal element. When can I say M is maximal? If and only if. If and only if I can say that for all elements. Okay, for all elements, if B is different from M, if B is different from M, then what will happen? then M is not related to B. Yes or no? Then M is not related to B. Tell me what will be the contrapositive? What is going to be the contrapositive? The contrapositive will be for all B, for all elements, I can say that if M is related to B, then M is B. Okay, then M is B. Is this clear? If M is related to B, if M is related to B, then B is M. Okay, this will be the contrapositive. So very simple. Remember, this is the definition of maximal. Okay, let's move on now. Tell me the answer for this question. What should I write here? X is what kind of element if X is related to B for all B? X is related to B for all B. X is related to B for all B. X is related to everyone. So this is the definition of least element. Okay. Tell me the answer for this question. X is what kind of element if B is related to X for all B? Means everyone is related to X. B is related to X for all B. This is the definition of greatest element. Okay. So very simple. Now let's see hash diagram of a total order relation. What is a total order relation? Do you remember the definition of total order relation? Total order relation means, when can I say a relation is total order? When it is partial order and every pair of elements are comparable. Yes or no? So it must be a partial order relation and every pair of elements comparable. Every pair of elements are comparable. Yes or no? So remember, every pair of elements must be comparable. Also, it must be a partial order relation. Okay, this is the definition of total order relation. Now, let's see some total order relations and let's see their hash diagram. There is very interesting thing about the total order relation hash diagram. Let's see some total order relations I am giving you. First, you tell me on this set 1, 2, 3, 4, or maybe 1, 2, 3, 7, on this set less than equal to, is this total order relation? First, you tell me, is this total order relation? Yes, this is a total order relation because it is partial order. It is reflexive, antisymmetric, transitive. Also, you can easily see that every two elements, you can take any two elements, they are comparable. Okay. Now create the hash diagram. Hash diagram of this total order relation. What that will be? You can see one is related to 2, 2 related to 3, and 3 is related to 7. So did you notice we are getting a chain? Okay, this type of structure we are getting. You have one element here, one element here, one element here, one element here. You are getting this kind of chain, you are getting a straight line. Okay, so this chain we are getting. This will happen for every total order relation. Let me tell you. Okay, you can take any total order relation. This will always happen. So that is the reason total order relation, if you remember, I told you that is called chain. Yes or no? Because hash diagram of total order relation will always be a chain. Okay, because hash diagram of every total order relation is a chain. Is a chain. So another name for total order relation is chain, or you can call it linear order, or you can call it linear order, or you can, another word is simple order. Okay, these are different names for total order relation. Okay, so you can see you are getting a chain. Now let me give you another total order relation. First of all, you tell me set of natural numbers and less than equal to, is this a total order? See, less than equal to, that is a partial order relation on any set of numbers. So yes, this is a partial order relation. And if I give you any two natural numbers, if I give you any two positive integers, they will be comparable. Yes or no? One of them will be less than equal to another. So I can say, yes, this is a total order relation. Now you tell me what will be the hash diagram. See, hash diagram is very simple. 1 is related to 2 because 1 is less than equal to 2. 2 is less than equal to 3. 3 is less than equal to 4, and so on. This is infinite or not? This is infinite chain. Yes or no? So again, very simple. You are getting a chain. Again, you are getting a chain. Of course, this is a infinite. Tell me here, what is the minimal element? What is the minimal? Minimal means no one else is related to me. So you can see one is minimal. Tell me what is maximal? Who is maximal? Which element is maximal? There is no maximal element, does not exist. Can I say infinite? Infinity is the maximal element. Can I say infinity is the maximal element? No, infinity is not even a number. Infinity does not belong to natural numbers. Infinity is not even a number. Not a number. Okay. Now, so very simple. What are the greatest element? For which element I can say that everyone is less than equal to this number? Again, this does not exist. And who is the least element? The least element is 1. Also, can you notice for this total order, the hash diagram is a chain. Okay. Now, let me give you the next one. The next is a set of integers greater than equal to. Can you create the first to tell me, is this a partial order relation? Yes, this is partial order relation greater than equal to. This is a partial order relation on every set of numbers. Okay, this is always a partial order relation. And you can see if I give you any two integers, then definitely they are comparable. One of them will be greater than equal to another. Okay, so I can say this is a total order relation. Now, can you create the hash diagram for this? Can you create? So tell me, can I say this is correct hash diagram? 0 related to 1, 2. Okay, can I say this will be hash diagram? Is this correct hash diagram? Tell me on your screen. No, this hash diagram is wrong. This is a wrong. Why? What is the mistake in this hash diagram? Because this is actually hash diagram for, this is hash diagram for less than equal to. This is hash diagram for z comma less than equal to. Okay, less than equal to. So remember, for this, the hash diagram, let's create the hash diagram for this structure. Let me create. For this structure, the hash diagram will be, remember, you can see 1 is actually related to 0 because 1 is greater than equal to 0. Yes or no? See, 1 is greater than equal to 0. 1 is related to 0 because 1 is greater than equal to 0. Yes or no? 0 is related to minus 1 because 0 is greater than equal to minus 1. So actually, if you notice, this 1 is actually related to 0. 0 is actually related to minus 1. That is related to minus 2 and so on. You can see 2 is related to 1, 3 is related to 1 and so on. This is the correct hash diagram. Again, you are getting a chain. Okay, is this clear? This is the hash diagram for z comma greater than equal to. Okay, so please don't make this mistake because our mind is very comfortable with less than equal to. We keep using less than equal to, less than equal to. So this type of mistake is possible. Okay, so always focus. What is the relation? What is the base set? What is the relation? Okay, so very simple point. Is this clear? Now, one thing that I want to tell you, that is, remember, for every total order relation, what will happen? The hash diagram will be a chain. Is this clear? For every, or I can say, for any total order relation, remember the hash diagram will be a chain. Is a chain. Okay, connected straight line chain. Is this clear? Tell me, is this a chain? If I do this 3, 5, 7, is this a chain? Is this a chain? Is this a chain? No, 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 no. Remember, chain means what? Chain means like this straight line. Okay, straight line, they are connected. So this type of thing is chain. So don't say that this is chain. Okay. So remember, chain is like this. Is this clear? Okay. Tell me one more thing. For example, is this a chain? If I put a 1 here, 2 here, 3 here, 4 here, is this a chain? Is this a chain? Again, this is not a chain. Again, this is a not a chain. Okay. So remember, chain simply means all the elements are in a straight line sequence. Okay, connected. So very simple. So remember, for any total order relation, the hash diagram will be a chain. Also, this is if and only if, means if hash diagram is chain, if hash diagram is chain for R, then what can you say about R? Then R is a total order. Is this clear? Then R is a total order relation. Because if hash diagram is chain, it means every two elements are comparable. Do you agree? If I give you hash diagram which is chain, this chain if I give you, okay, this chain if I give you, then can you notice every two elements are comparable? Because there is a upward path. This element will be related to this element. Yes or no? So if I give you a chain, then every two elements will be comparable. Is this clear? Please tell me. So very simple point, that if hash diagram is a chain, then the relation will be total order. And if relation is total order, then hash diagram is chain. So remember, total order relation and chain. Okay, these two things, they are if and only if. Okay, if you get the hash diagram, you create the hash diagram. If you get a chain, then it means it is a total order relation. If it is not a chain, then it is not a total order relation. Yes or no? Is this clear? So remember, total order relation, hash diagram is chain. Okay. Also, if not chain, then it means not a total order relation. Okay. So this is also two-way. So I hope you understood. Okay. Very simple. Now let's move on. Tell me the answer for this. Is this a POSET? Divides relation on this set. Is this a POSET? Please tell me. Yes, this is a POSET. You can easily see reflexive, antisymmetric, transitive. These properties are satisfied. So yes, this is a POSET. You can check. Okay, now you tell me, is this a TOSET? Can I say every two elements, they are related to each, they are comparable? Every two elements are comparable. Yes, every two elements are comparable. Okay, tell me, are these two elements comparable? Yes, 2 divides 8. Are these two elements comparable? 4 divides 16. Now create the hash diagram. Let's create the hash diagram. So you can see 1 divides 2, 2 divides 4, 4 divides 8, 8 divides 16. Did you get a chain or not? Did you get a chain or not? Yes, the hash diagram is chain. See, so because hash diagram is chain, so what you can say? Tell me. If hash diagram is chain, then it simply means it is a total order relation. Okay. So very simple point. Let's see this question. Set X is given to you. Set A, these are the elements. Okay, A, B, C, D. Only 4 elements are there in this set X. Now we have this subset relation. Okay, we have this subset relation. First, you tell me, is this a partial order? Yes, this is always a partial order. I told you that subset relation is always a partial order relation. Okay. Now, tell me one thing. Tell me one thing. Will you will you check for total order, or will you create the hash diagram? Which is more easy? Directly checking total order or hash diagram? Different questions, for different questions, maybe this can be easy or maybe this can be easy. Remember, okay, sometimes directly checking total order is easy and sometimes hash diagram is easy. I'm telling you. Okay, depends on the question. Sometimes for some questions, directly checking total order means every pair of elements are comparable. Okay, that is easy. And sometimes for some questions, hash diagram is easy. For this question, hash diagram is easy. So I will create the hash diagram. Okay, let me create the hash diagram. So you can see this element is related to this element. This element is related to ABC, and ABC is related to ABCD. Did I get a chain? Did I get chain? Tell me. Did I get a chain? Let me know. Yes, we got a chain. Okay, so that automatically means it is a total order relation. Okay, is this clear? Very simple. Now let's move on. Now, this is an interesting question I'm giving you as a homework. The first one I will do, the remaining you can do. Okay. So the first one I will do. The question is asking which of them are total order. So 3 questions you have on your screen. Okay. Let me give you the answer for the first one, and the remaining two you can take as homework. Pause the video, write your answer in the comment. Okay, video solution you can find in the pinned comment. Okay, so let's see the first one. I'm taking this first one. This is the base set. R is a relation. This relation is given to you. First, what you will check? I want to check total order. So for total order, what we need to check? We need to check, is this a partial order relation and every two elements comparable? Every pair of elements comparable? Yes or no? Every pair of elements comparable. So tell me, is this reflexive? Yes, this is reflexive. A related to A, B related to B, C related to C, D related to D. This is your base set. So yes, this is reflexive. Okay, there is no problem in the reflexive property. What about the antisymmetric property? Tell me. What about antisymmetric property between different elements? Do you have A related to B, B related to A, this type of situation? Do we have C related to A? Do we have A related to C? No. A related to D. Do you have D related to A? No. C related to D. Do we have D related to C? No. B related to C. Do we have C related to B? No. B related to D. Do we have D related to B? No. So again, you can easily see this is a antisymmetric also. Okay. For transitive, what you will do? For transitive, you will create the graph. Okay. For transitive, just create the graph. So you can easily see you have A, B, C, D. Okay. Just create the graph. You can see. Okay. They have self loop. Everyone has self loop. Just create the graph for transitive property. Now you can see C related to A. Okay. A related to D. C related to D. Okay. So far, transitive property is satisfied. Yes or no? Next, B related to C. B related to D. So far also transitive property is satisfied. Also, you can see B related to A. Okay. So again here, you can easily check that transitive property is satisfied. Okay. There is no violation of transitive property here. You can just easily check. Is this clear? Please tell me. Okay. You can check the transitive property will be satisfied. Now let's create the hash diagram. Okay. So the hash diagram, let's create. You can see that. Tell me from where to start? From which element to start? What do you think? Which element is related to most of the elements? Okay, don't worry, don't worry, don't worry. Let's just start from C related to A. Okay, let me assume, let me think like this. I am thinking C related to A. Okay, let me think. A related to D. Let me think. C related to D. Will I put it? Will I put it? See, I am putting C related to A. I am putting A related to D. Will I put C related to D? That is already transitive age. So there is no need. B related to C. Okay. B related to C. B related to C. Now, what about B related to D? Will I put it? B related to D. Will I put it? No. That is transitive age. Yes or no? That is transitive age. Will I put B related to A? No. That is transitive age. So that's it. Yes or no? We got this hash diagram. Is this hash diagram a chain? This hash diagram is a chain or not? If it is a chain, then this is a total order relation. Okay, is this clear? So yes, this is a total order relation. Please tell me, did you understand? Let me know. Now let me tell you a very quick method. See, a very quick method. If the same question comes in the GATE exam, then very quickly, how can you do? If this type of question comes where you have all the ordered pairs are given to you, then tell me, will you check for transitive property, antisymmetric property? Will you check like that? See, first we are checking transitive, reflexive, antisymmetric, all these things we are checking. Then we are creating the hash diagram. Okay, it is taking time. Yes or no? So let me tell you, for this type of question where you have set representation, where you have set representation of few elements. Okay, yes or no? Few elements. Actually, here what you can do without checking, just check reflexive. That is very easy. Okay, first you just directly check reflexive. Please check reflexive. Yes, reflexive we have checked. Okay, so don't become lazy for reflexive. Yes, reflexive we have checked. Now what you do? Now directly create the hash diagram. Okay, see, if anti-symmetric property is not there, then you will see there is some kind of problem. Yes or no? What you do, what I'm suggesting you now directly try to create hash diagram. Now directly try to create hash diagram. Okay, please tell me one thing. When you are creating hash diagram, and let's assume anti-symmetric property is not there, then definitely this type of problem will come. Okay, and if this type of problem comes, you can say, okay, not anti-symmetric, so so not a partial order relation. Okay, and tell me similarly, if it is not transitive, then also problem will come. Then also problem will come. Okay, so again, let's try to create the hash diagram. Let me try to create. Let's start with C is related to A. Let me directly start here. A related to D. Let me start here. C related to D. Will I put it? I will not put it. I will not put it. But one thing is there. See, this must be there. Yes or no? For example, let's assume in the question this is not there. Now, immediately you can notice that transitive property is violated. Okay, please notice transitive property is violated. If this is not there, then transitive property is violated. Okay, so this is there. That is a good thing. That is a good thing. Okay, B related to C. B related to C. Now, B related to that is a good thing. That is a good thing. If it is not there in the question, if it is not there, then transitive property is violated, and this will not be a total order relation. Similarly, B related to A, that is a good thing. Okay. So this is the hash diagram you got. Transitive property is also satisfied, and it is a total order relation. But anyway, one thing I want to tell you, if you directly create the hash diagram, then please take care about the transitive property, because for example, let's assume this is not there. Now it is possible you can create the hash diagram directly. Yes or no? If it is not there, if this is not there, then definitely it is possible you can create the hash diagram, and you will think that it is transitive, but actually it is not transitive. So anyway, I think you should check. Okay, I think you should check transitive. Okay, I think you should definitely check transitive, else you will make a mistake. Else you are going to make a mistake. Okay, if you don't check for transitive, you are going to make a mistake. But antisymmetric property, there is no problem, because if antisymmetric property is violated, then this type of situation will come. If antisymmetric property is violated, then this type of situation will come. Okay, but antisymmetric property checking is also very easy. Okay, I think you can just remove it. Okay, just remove it. Just check antisymmetric, because checking antisymmetric property is actually very easy. So first you check these three things, and then you create the hash diagram. Now you create the hash diagram. Okay, if hash diagram is chain, then it will be a total order relation. Okay, so like this you can do. Okay, anyway, so remember, okay, check reflexive, transitive, antisymmetric. Don't forget to check these properties. Once these are done, it means it is a partial order relation. Now create the hash diagram. For every partial order relation, you can create the hash diagram. If your hash diagram is chain, then it is a total order relation. Okay, very simple. These two remaining questions, can you try? I'm giving you as a homework. Okay, so please take these questions as homework. Pause the video, solve these questions, write your answer in the comments. Okay, so these are good questions, let me tell you. For example, this is a good question, this is also a decent question, so you can check it. This is actually a good question, you should try. This is another very good question. Again, this is also for your homework. The question is saying that partial order relation is given to you, so will you check for partial order relation? This is already given that let T be a partial order relation. So you don't have to check partial order or not. The question is saying, is it a total order relation? This relation is given, X related to Y, if and only if either this happens or this happens. Okay, the question is asking, is it a total order relation? See, the question is saying it is a partial order relation. So you don't have to check reflexive, antisymmetric, transitive. But you have to check that every two elements are comparable. Every two integers are comparable. Okay, yes or no? So the question is asking, is it total order relation? Yes or no? Maybe this is total order relation, maybe this is not total order relation. So you have to check it. and write your answer in the comment. Okay, video solution you can find in the pinned comment. Very simple. So that's your chapter. We have seen what is a partial order relation. Partial order relation is a relation which is reflexive antisymmetric transitive. We have seen what is hash diagram. Hash diagram is created for partial order relation. This is a drawing of partial order relation in which we don't put the self loop, we don't put the transitive edges, we don't put the directions. All the edges are in upward direction. We have seen what is a total order. Total order is a partial order in which every two elements are comparable. So this is the complete summary. We have already seen everything. This is your POSET complete summary. So POSET is over. POSET complete summary is over. Okay, we have seen the complete summary, all the concepts and many examples we have already seen in the lecture. Some homework questions I have given to you, some very good questions I have already solved in this lecture, and some beautiful questions I have given you as a homework. So please solve those questions, write your answer in the comments. I will also tell you whether your answer is correct or not, and the video solutions you can find in the pinned comment. Okay, is this clear? So thank you everyone. Please like this session and please put your comment. Okay, all the homework questions that I've given to you. Okay, pose every question, solve it, write your answer in the comment, then go to the next homework question and then do it. Okay, so please like this session and please put a comment. Okay, thank you.